Hey, so in our last conversation, we talked to Bob Unger, learned a lot about how he got started in industry, learned a lot about TAFA and just some of the people involved with a whole lot of fun detail I just didn't know about. So it was really good talking to him. In this next segment, we're going to talk about wires to dive much more deeper into wires, their nature, how they're different for thermal spray, what a cord wire is. And at any rate, just enjoy this part of the conversation. We had a lot of fun recording this one also.
First off, I focused on bringing in sales because, I had this worldwide network as I'd been traveling the world. I knew every distributor in every country all over. And so I went to, and built a network around the world to sell wire and immediately built that business. But what was really exciting was that having the capability of making cord wires. With solid wires, you can't do a lot of new stuff. Okay. I mean, there's alloys out there. All right. But, if you got an application, you got to look, okay, what alloys exist? Because, to make a new solid wire is like an act of God. You got to make 40,000 pounds or whatever. But with cord wire, you can just whip it up. It takes a strip. You put some powder in, you can make 50 pounds and you're on your way,
Well, Bob, let's talk about that a little bit more because you made that sound very simple, and it is to you. First of all, tell the difference between how solid wire is made and how is a cord wire made, and what does it mean, cord?
Okay. Yeah, so solid wire, and this is how traditionally most of the wires are made, is you cast a rod, okay, typically, I don't know, a 1/4-inch rod diameter, and it's done with this thing called continuous casting, and then you draw it through dies, all right, and bring it down to size. You can't bring it all the way from 1/4-inch to, thermal spray typically uses 16th inch. So, you jar it through about maybe 5-6 dies, depending on the type of material, and it brings it down to size, and then that can be sprayed. With a cord wire, it's actually not CORD, it's CORED, all right, which means that there's you take a strip, the strip maybe is, I don't know, half an inch wide and 10 thousandths thick, and it goes through what's called a tube mill, and and it goes ahead and forms it into a U. It goes through some rollers, and the strip is formed into a U. It's a continuous, manufacturing process, and then there's a powder hopper where powder mix has been put together. The trick is, you take the chemistry of the strip. The strip can be different materials. It can be stainless. It can be iron. It can be copper. It can be anything that's available as a commercial strip. But you can also, there's all kinds of powders that you can get, chromes, mollies, whatever. So you decide the composition you're looking for, and then you figure what the strip head for composition, what the powder is for composition. The powder drops down into the strip. Then it goes through the dies, same type of dies that you're doing with a solid wire, and at the end you've got a 16th inch wire that we call a cord wire. So it's actually like a cigarette. It's got a
it's a hollow core that you put powder in.
Yep, absolutely.
Yep.
Yeah.
Excellent.
And so what was nice is very quickly, when someone would approach you with a new application, it's a corrosion, had some wear, this type of thing, rather than just look at what's currently available, you're able to actually engineer something new, all right, specifically to solve that problem. And we did a lot of those, and that was the most exciting part for me. Obviously, the commercial business, we need to bring in sales, and so we do a lot with the existing alloys, but we created some pretty unique new alloys. A good example is this product we call 860 BC. One of the applications that I've really been involved in since I started way back in the early 80s was boiler tubes. When a lot of the way that our power is created, is coal-fired boilers, where you burn coal, and basically a boiler is this huge building. When you drive down, you see these things with the big sparks coming out, and they burn the coal. And the boiler itself is lined with tubes that have water inside, and the heat from the burning coal turns the water in the tubes into hot steam, which then goes to a turbine and generates electricity. And that's been around forever. But these tubes, they are subjected to a lot of heat and flying ash and whatever with all this coal burning. So they wear out. Okay, they corrode. They see abrasion. They see erosion, and as they wear out, they start to get thinner, and then they need to be replaced. Thermal spray has, at least in my lifetime, and I've been pretty instrumental in getting this established. You can put a coating on those tubes of a very hard, corrosion-resistant material, and the tubes will last 10 times longer. And when the coating's gone, you can just recoat them 10 years later. So the tubes will virtually last forever. One of the materials that was being used relatively commonly for the corrosion part of it was Inconel 625, which is a very corrosion-resistant nickel-based material, and but it wasn't particularly hard. All right, it was, I don't know, maybe 95 Rockwell B, somewhere in that range. So what we did at Polymet is we created basically an Inconel 625 type strip, in which we put boron carbide, which is a very hard wear-resistant material. So what the end result was a cord wire, or that's what the BC is, 860. BC stands for boron carbide, and it produced a very corrosion-resistant coating, comparable to Inconel 625, but very, very hard. Okay, Rockwell's 70. HC70. So it's really done tremendous in the market for boiler tubes, because it probably combines the best wear resistance and corrosion resistance of any material I know.
Yeah. So along those lines, Thermal Spray Depot is working with Polymet right now, which right now is a proprietary material, but we're looking at being able to do inside diameter coatings using some special technology and using a custom wire that I'm working with Bob on. So we can play around with that at relatively low cost. As Bob said, we can produce small lots of this wire and be able to experiment with it and see if we're getting the right properties. So really excited about this, because there's a real need out there right now for inside diameter coatings of hydraulic cylinders and that type of thing. So we're working on that with Bob right now. So it's really good, exciting stuff. But there's some other things too you're talking about, Bob, that are relevant to customers buying wire, particularly the things like 420 stainless as a solid wire. And as you said, they go through dyes, and each time they go through dyes, there's something called cold work that goes into the wire. And once that cold work is in there, you have to relieve the stresses from that cold work by running it through a heat treat process. And when you do that, very often the outside surface gets a little rough. So that's one thing that happens with the wires, and Polymet has a finishing process where they get rid of that roughness so that doesn't affect the thermal spray guns. Another thing that happens in the thermal spray manufacturing process, so we have two things, one called helix and one's called cast, which can have a very negative effect on your thermal spray equipment. And if you combine that cast problem with a rough surface, it really makes a problem in your gun. So Bob, maybe talk a little bit about what is helix, what is cast, and how do you deal with the surface roughness of these alloys?
The feeding of wire, all right, is critical in thermal spray. It's certainly an arc spray. You've got two wires and they have to feed consistently, or you get popping and spitting. You get wires stopping and welding in the contact tips. So wire feeding is critical. You look at some people ask sometimes, well, what's the difference between a welding wire and that I'd get from the welding supply store and something I'm going to get from Polymet? And the answer is putting the exotic cord wire special compositions aside, with the more generic materials like stainless steels, coppers, those type of things, compositionally they're the same. Okay, I mean they might be both 95% copper with a little bit of this and a little bit of that, but when you get to the things you mentioned there, surface finish, cast, and helix, those things are critical to the wire being able to feed consistently and properly into the gun and give them a coating. So what we do is, as you mentioned, yes, when you draw wires, they work harden, and then you have to anneal them, at which point you may get some roughness to the wire and a matte finish. So we control that, all right, so that we give a shiny wire that will feed very, very well. The other thing that's critical is you mentioned cast and helix, and that you take these wires, okay, I mean, ideally they'd be perfectly straight, but you're winding them onto a 12-inch diameter spool, which has a core of only maybe 6 inches. So, you're winding them relatively tightly. And they take a set, all right, so that you to be practical, you can't just use 100 pounds of something straight. You couldn't ship it, you couldn't do anything with it. So you have to put it on spools. So the cast is what the curvature of the wire is. Okay, if you take 10 feet of wire off the spool and cut it and drop it on the ground, you'll see it forms a circle. And you want that circle. It's very important. It always surprised me that it's as important as it is. You would think that some of these subtle differences wouldn't make that big a difference, but they do. Okay, it's unbelievable. They really do. So when you look at that circle that forms, it needs to be typically between about 20 and 50 inches. Those are the upper and lower limits that we use at Polymet. Because if the circle is smaller than that, it's real tight, and what happens is as it's going through the conduit into the system, it sees a lot of drag because this curvature is dragging along, rubbing the conduit the whole way. When it gets up to the tip, it can be flipping around. So it's a real problem. And so
that's what we call cast, correct? That's what we call cast.
And even more important is what they call the helix, which the end of that wire, I mean, ideally you'd want it laying perfectly flat on the ground, that circle, that the 10 feet that you just cut. Okay, but the end will rise off the ground a small amount. Okay, and typically the helix you want to be no more than 1 inch, and you wouldn't think something with 3 or 4 inches would be that big a deal, versus 1 inch. But as I said, it really is. Okay, and again, it's what it's doing is allowing the wire to flow freely into the gun, and get through the tip, meet the other wire, and melt. So, it's really and the last issue is lubrication. Okay, some wires, like aluminum's a good example. Okay, it tends to gall when it's rubbing along the conduit. So certain wires are lubricated. Okay, in order to also enhance feeding, and that's a real art as well, because if you get too much lubrication on the wire, it's going to gum everything up on the wire path, and they're going to be cleaning it all the time. And if you don't have enough, it might have trouble feeding. So all these things are things that Polymet has really does a good job with. I think best in the world, frankly. And
sure. I agree with you. One of the questions on the lube, Bob, is okay, so you got lube in this wire. Aren't you going to spray that onto the part? I mean, it's going to go through this arc spray gun. You got this lube all over. What happens to the lube when it hits the thermal spray gun?
It burns up in the arc. I mean, the arc is tremendously hot. Arc spray is an interesting technology because we say it's a very cool spray. But the arc itself is extremely hot. It's 10,000 degrees Fahrenheit. So that stuff, it's carbon based. It's gone. It burns up. The coatings have been tested. Nothing gets in there. It burns up. Okay, the the beauty of arc spray is, okay, you got an extremely hot arc, so the particles get real hot, whatever. But whereas the other processes tend to have a hot gas or plasma that's propelling the particles, what that ends up resulting in is the coating gets extremely hot. Okay, if you're doing 30 kW, all right, 2 kW goes into melting the wire, and the other 28 kW is impinging on the part. Well, what does that do? It gets hot, which raises stress. So consequently, the bond strength goes down. You can get cracking and all these things. With arc spray, it uses that 2 kW to melt the wire, but that's it. Okay, there's no other heat at all. All right, and along with that, you have a tremendous flow of cooling air that's propelling the particles, so the coatings stay very, very cool, which is one of the reasons that the bond strength is so good, and you can build the coatings up so good.
Sure, and that makes total sense, because as we know that the coating goes on, it's very hot, and it's cooling down. It's got that hoop stress in it, and that causes a tremendous amount of stress on there. So most materials are melting well below 3,000 degrees Fahrenheit. So those molten particles that are going through the air are somewhere around that 3,000, and you're hitting that with a cool air. So naturally, you get a much cooler coating going on. Whereas, as you said, if you've got these hot gases that might be 7,000 degrees Fahrenheit coming out, you're heating up that whole gas stream. I think they call that enthalpy, if I have the term right. You've got all that enthalpy. It's got to go somewhere, and it's going to go onto the part. Yeah, so excellent stuff. Bob, does Polymet subcontract this to send their stuff out, or does Polymet have their own mill that they make their own wires with?
No, we make our own wires. I mean, our real forte is the cord wires, okay, which we do, but we also have the capability of doing solid wires as well. We can draw wires. Most of the commodity materials, such as, like you mentioned, 420 stainless, that's kind of the workhorse of the thermal spray industry. We don't draw that. There's people that specialize in it, and they can do it a lot cheaper than we can. So those, we will typically buy the material. We do bring it in-house in big reels, and then we process it, spool it, control the cast and helix and all the stuff we talked about, the lubrication, and get it onto the spools, so that my commitment when I started to the customers, you buy it from Polymet and it's going to work. Okay. You're not going to have difficulties. If for some reason there was anything, no questions asked, we're going to make it right. Okay. So they understand that, they buy 420 stainless off the welding supply house. They don't know what they're getting, and they can have all kinds of trouble. They get it from Polymet. It's going to work every time. But so we have all the capabilities, Bob, and to make our materials in-house. Yep.
And I can attest to that. I mean, literally, we've sold millions of pounds of wires together. And over those years, over 20 years, I only can think of one return. And that return, I really believe, was an application problem from the customer. They just didn't really know what they wanted. And Polymet worked closely with them, said, yeah, return it. We'll take it all, all unopened, spools took back with no problem. But again, I don't really remember any quality issues. It's been a great relationship that way. It's been really an honor to be able to distribute the Polymet wires over the years.
Well, it's been great to have you part of the team. It's, as I said, we've done some good work together.
Yeah. And what other interesting to kind of go backwards too, when you had gone to Polymet, I think we started selling for Polymet probably a year after you got there. It was pretty close to when you got there. So we like to think that Thermal Spray Depot has been part of the growth for Polymet, helping them to move along and grow. And we have our own segment of the business that we have a mutual friend who's also named Bob. He used to say that there's closets of business out there that are right underneath your nose. You don't even know they're going on. So I had some closets of business that we've accumulated over the years that turned out to be some pretty successful customers, and we're very happy with that relationship.
Yeah. Well, it's for sure. Yeah, well, I went to Polymet in 2004. You just put the timing in.
Yeah.
It's interesting. I talked a lot about TAFA. I was there for 21 years as sales manager, and now I'm in my 20th year at at PolyMet. So,
Yeah, Thermal Spray Depot, actually, we started doing business kind of out of a closet in 2001, and we made it formal in 2002. And that's when we established the LLC, and we went at it full time, real hard, and it's been a great ride. Yeah. Well, Bob, this has been a great perspective on PolyMet. Again, I've been doing business with you guys for, like I say, 18, 20 years, whatever it's been. And we have had no quality issues. We had maybe one return over the years, and that was a customer application problem. It had nothing to do with the wire quality, but you honored that return. It was not a problem. And we even had some overruns where we had customers use more wire than they needed, and you took that back. It was an unopened spool, so it was no problem. But that kind of business relationship is hard to find out there anymore. And certainly the manufacturing process, I've been out to the plant in Cincinnati, and Thermal Spray Depots welcomes anyone that wants to go out to PolyMet to see the mill. I'll join you. We'll go out there and take a look at it and meet Bob in person and take a look at how wire is made. If you have any other questions on wires, applications, how it's made, how to use it. And if you have questions on special formulation that you want to play around with the special development project, give me a call here at Thermal Spray Depot, 724-229-5791, or drop me an email at bob@thermalspraydepot.com.